This question says, use the vertical line test to determine whether the graph is a graph of a function. So with the vertical line test, what you're supposed to do is draw vertical lines all over the graph. And as you draw the vertical lines, you're going to check how many times that vertical line is crossing the graph. So for each one of these vertical lines that I've drawn, the vertical line is crossing the graph in one place. So if your vertical line crosses in 0 or 1 places, we can categorize that graph as a function. And if those vertical lines cross in more than one place, we would categorize those as not a function. So for this example, because every vertical line crosses the graph in one place, exactly one place, we would say that this is the graph of a function. So that is the definition of a function, that every x has exactly one y. And that's what the vertical line tells us, that we have one y value for every one of the x's. And those vertical lines are representing particular x values. So for example, if we had a graph like this, a sideways parabola, and we did the vertical line test, we would notice that the graph crosses, or the vertical line crosses the graph in 2 places, and this is not a function because we have an x value with 2 y's, and that violates that definition of a function. This question says, classify the given function as a polynomial function, a rational function, or a root function, and then find the domain. Write the domain in interval notation. So our function is h of x equals 4 over x squared plus 25. This type of function is a rational function. And the reason why I know it's a rational function is because it has a variable in the denominator. So in general, rational functions will be of the form p of x over q of x. P of x and q of x are polynomial functions, and our denominator is not allowed to equal 0. So when I look at this equation, I notice that I have a fraction, just like I have with the rational function up here, and both the numerator and denominator are polynomial functions. So this is the key to finding the domain. Q of x is not equal to 0, and the reason why our denominator cannot equal 0 is because division by 0 is undefined. So that's going to be our strategy for finding the domain. So since rational functions are in the form of a fraction, there's a restriction that the denominator is not 0. You can find the restricted values by creating an equation. The equation is the denominator equal to 0. Q of x is our denominator equal to 0. The solutions to this equation are the restricted values and must be excluded from the domain. So that's what we're going to do. We're going to take our denominator and we're going to set up that equation by setting it equal to 0. This is going to tell me which values are restricted and which values need to be excluded from the domain. So I'll solve this by subtracting 25 on both sides. That gives me x squared equals negative 25. And I can get rid of the squared by square rooting both sides. And I get x equals plus and minus. Square root of 25 is 5, and square root of negative 1 is the imaginary unit I. So these would be my restricted values. Now when we're talking about domain, we only consider the real values, the real numbers. And since we got an imaginary number here, we can say that there are no restrictions. And since there are no restrictions, our domain will consist of the entire number line, which is negative infinity to infinity. So the domain of this rational function is negative infinity to infinity. This question says to graph the line that contains the point negative 3, 3 and has a slope of 2, 3. So to graph the line, I'm going to plot that point negative 3, 3 right here. And then I need to find a second point on the line using that slope. So we have to remember what slope stands for. Slope is rise over run, or the change in y over the change in x. So I can start from that point that I plotted, negative 3, 3, and rise to, so I'll go up 2, I'll change y by 2, and then I'll change x by 3, so I'm going to run 3. And that's going to lead me to a second point on that line. And with that second point, you only need 2 points to graph a line. I'll be able to draw that line that connects those 2 points. So there we've drawn the line that contains the point negative 3, 3 and has a slope of 2/3. Use the graph y equals f of x to answer the question. For what values of x is f of x less than or equal to 0? And we're given this graph in red is the graph of f of x. So for what values of x is f of x less than or equal to 0? So what we have to remember is that f of x is the same thing as y. So we're saying when is y less than or equal to 0? For what x values is y less than or equal to 0? So let's make sure we understand how this graph works. We have our y scale, which is right here, and on our y scale we have right here the origin, that's where y is equal to 0. Then we have these points here. We're counting up 1, 2, 3, 4, 5, and then counting this way would be counting down negative 1, negative 2, and so on. So when we look at this picture, we kind of use our x-axis as a divider. That's where y equals 0. When we look above the x-axis, that's when y is greater than 0. And when we look below the y-axis, I'm sorry, not the y-axis, the x-axis, that's when y is less than 0. So let me make it even more clear what I'm talking about here with some colors. So with y equals 0, that's on top of the x-axis. When y is greater than 0, that's above the x-axis. And when y is below 0, that's below the x-axis. Okay. So that's going to help me figure out when y is less than or equal to 0. Now my picture is a little bit messy now, so let me erase so that we can see this picture more clearly. And we can see, I'm going to trace the graph. This piece of the graph is below the x-axis. This piece of the graph is also below the x-axis. Below the x-axis, that's when y is less than 0. We want when y is less than or equal to 0, so we also want points that are on the x-axis. So we're going to include these endpoints here that are on the x-axis. And also this point over here that's on the x-axis. So what I'm looking for is what are the x values? So looking at this first piece here, looking at this piece right here, I need to know the x values for that. Those x values start at -6 and end at -11/2. I'm going to put a parenthesis on the -6 because there's an open circle on this end. And I'm going to put a bracket on the -11/2 because this is a filled in dot. That's when y equals 0. Then when I look at this next piece, this piece here, that piece starts at -2, an x of -2, and ends at an x of 7. I'm going to put a bracket on -2 because -2 is on the x-axis and y equals 0 on the x-axis. I'll also put a bracket on 7. And then finally, I need to include this point right here on its own. It's not an interval, it's a single point. So I would include on its own +11. So these are the x values where y is less than or equal to 0.